All right, welcome everybody to week 11, day 2. We're going to be continuing our discussion of classes today. And today we're going to show you how to use classes and vectors and functions, things like that, things that are just pretty common uses of classes. So if we were to open up the server and main.cc, and we go ahead and make a point class, and the point class has a x value that's initialized to 0 and a y value that's initialized to 0. This is a pretty common class kind of thing that is used in a lot of different disciplines, areas, simulations, gaming, physics. This is a 2D point. Sometimes we will do a 3D point as well, but to keep things simple, we will do a 2D point. So without having classes, let's say you wanted to have, let's say you wanted to hold 10 points. Before you knew what classes were, I remember classes and structs were the same thing. Structs is just default to public, so it's a little less typing. You'd have to do something like this. You'd have to say vector of double named x's and y's, something like that, of size 10 and of size 10, and you'd have two different vectors, one holding all the x values, one holding all the y values, and just hope that they don't ever get out of sync. And this is really stupid and awkward. So instead of doing that, what we do is we make a vector of points. Okay, named points. And then we can do things like we can make it have 10 points, right? And then we can say like points dot at 0 dot x is equal to 10. And points dot x points out at 0 dot y is equal to 0. So this so points 0 is basically equal to 10 0, and you can actually write that if you want. Points or bracket 0 is equal to 10 0. That actually works just fine. It does the same thing as these two things. These two lines are the same as this line here. And whatever you put in first inside of the curly braces is the first member variable here. Okay. And the second one is y, and so y is set to 0, x is set to 10. You can use square brackets, you can use dot at. For this class, I recommend using dot at for bounds checking, because if you screw up, then dot at will tell you that you screwed up. Whereas if you do it this way, what's going on here? Whereas if you do it this way, who knows what will happen? You are indexing out of bounds. Okay. Nobody knows what will happen. This is undefined behavior here. Does anyone know why it is undefined behavior? All three of these are undefined. UB, as we say in the business. Why is this? Why are all three of these lines here undefined behavior? It's supposed to be from 0 to 9, not 1 to 10. No, it's supposed to be from 0 to 9. Undefined behavior is my favorite kind of behavior. Yeah. It's undefined behavior is in the standard for a reason. Like, it means that the compiler doesn't have to check for things that you're not supposed to do. And technically, when you do undefined behavior like this, the compiler can do anything. It can crash. It could not crash. It could just access whatever is in RAM there. Does anyone know why this is undefined behavior? What did I do wrong? It could have it play the Macarena. It could delete all the files in your hard drive. Anything is possible under the standard, because once you've got undefined behavior, the compiler can do anything it wants. It's accessing elements that don't exist. Exactly. So we wanted to make 10 points, but we forgot. So now we've got 10 points. Well, let's just find out what happens. So if we do this and run it, maybe it'll segfault. Okay, so we got a segfault. Cool. Didn't have to. You can do anything once. So if we do this, though, then everything is cool. All right. And so we could see out points at 0. Yeah. It's like if we go back to how it was before, and if we use .at instead of square bracket, what you'll see is it'll actually throw an exception. It says you tried accessing 0, which is outside of the range when you have size 0. So I recommend you guys use .at for everything in this class. You don't need speed in this class. You just need safety. Okay. Let's come back in here, make it have 10 points. And then we can make another point. So we could say points .at 1 .x is equal to 0. Points set at 1 .y is equal to 10. So we've got 1 point at 10 0, and we've got 1 point at 0 10, and we want to like add them together. This is something we do a lot in physics. If you have a car traveling east at 10 miles an hour and it throws a baseball north at 10 miles an hour, then the baseball comes out with a vector heading east at 10 miles an hour and north at 10 miles an hour. And so if we add a member function here called the distance from origin that returns the square root of x squared plus y squared, i.e. the Pythagorean theorem, this will tell us the velocity, there we go. This will tell us the velocity of the baseball. Okay. So if we make a new point, we could say like point Bob is equal to points at 0 x plus points at 1 x, comma points at 1 0 y plus points at 1 y. And this would work. Okay. So this is going to make a new variable named Bob of type point. We could store it in the vector if we wanted to. We could say, for example, points at 2 is equal to the sum of points at 0 and points at 1. And it's this kind of like long, kind of somewhat annoying thing. And then we can see out points at 2 x, points at 2 y. And we can see out how far away it is from the origin. Okay, so what are we going to get if we add together 10 0 and 0 10? What values is the sum going to have? So points set at 2 is the sum of points set at 0 and points set at 1. What is the sum? What is 10 0 plus 0 10? It's not 20, it's a point. So it's got 2 values in it, right? So you're going to have to give me 2 numbers. It's going to have an x value and it's going to have a y value. It's going to be 10 10. Yeah, very good. The x components add together, and that's the first part. You see the comma there. And then the y components add together, and that's the y component. So 10 0 plus 0 10 is in fact 10 10. And what is the size of that? If we take the Pythagorean theorem, we got a 10 10 triangle. What's the size of the hypotenuse? How far away is 10 10 from the origin? So if we're traveling east 10 miles an hour, we throw a baseball north 10 miles an hour. How fast is that baseball actually traveling? Not 20. It's not 10. How fast is it traveling? It's between 10 and 20. It's not 100. How fast is the baseball traveling? 15? Close. Yep. 14.14. Very good. So plus main.cc. You'll see the sum of 0 10 and 10 0 is 10 10. And its distance from 0 0 is square root of 2 times 10. Okay. So like I said, this kind of stuff is used all over the place. Anytime you're simulating anything involving the real world, involving like engineering or like simulations of fluid dynamics or video games and this kind of stuff, there's going to be some sort of point class usually, and sometimes called a vector 2D or something like that, 2D point. This is a little bit awkward, and I don't want to do this every time I add two points together. So I can make a function to add 2 points together. And so learning point 1 for today, you can put classes into a vector. Okay. Learning point number 2, you can pass classes to functions and stuff. You can use member functions or free functions to do the same thing most of the time. Okay, so let me show you what I mean by that. So I can make a member function of point that takes another point and returns the sum of the two. So if I'm adding 2 points together, the return value is going to be a point. I can call this add. And I could take in another point named p, I guess. And then I can say point right val, the return value, and the return value's x component is my x component plus the other guy's x component, and the return value's y component is my y component plus the other guy's y component, and then I can just return right val. I'm passing in a point here. Should this be passed in by value, by reference, or by const reference? Is point a primitive? Right? How should I pass this guy in? By value, by reference, or by const reference? Vote now. Should be const reference. Very good. Okay. It would work with call by value, but in the general rule of thumb is to pass in anything that's a class by const reference. Okay. General rule. Exceptions sometimes exist. I could probably do this on one line, actually, if I really wanted to like hurt your brains. So I could actually do this. That's option 1. Option 2, if you really wanted to be compact, you could return x plus px, y plus py. This would also work. So you can just do that. It's a one-liner, if you want. This is probably a little bit easier for y'all to understand. So what's happening when you call this? Let's come down here and actually call this. Okay, so we can do option 1, no function at all, and then option 2 would be saying points.at 0.add. So we now have made a function on the class. So classes are a combination of variables and operations on those variables. Okay. That's really what a class is. It's a combination of variables and functions, really. So if we want to be able to add 2 points together, then it makes more sense to have it be a function rather than doing it by hand like this. So if we've got a point here, we could say points.at 0, or if we want to be more compact, we can say points square bracket 0 dot add points square bracket 1. So this is option 2. Use a member function add 2 points together. Okay. So this thing here and this thing here are doing the exact same thing. So it's setting the second element of points to be just use square brackets consistently to make it a little bit more compact for you. So it is calling a member function on a point, passing another point to it, adding their x components together, adding their y components together, and then returning the value. So this is my x value, and it's adding to the other guy's x value. It's taking my y value and adding to the other guy's y value. And in fact, you can actually say, if you want, this points to x, and this points to y. If you want to make it really clear that we're talking about my x and not your x, you can do that. It does absolutely nothing, like there's no difference, but you can do it. Some people prefer coding that way, just to make it like really clear that we're talking about my x value and not your x value, right? Fresno State likes coding this way. So you'll probably see this if you go to Fresno State. It's probably pretty common there. There's literally no difference between the two things. I prefer writing more compact code. Right? I don't write things that don't do anything usually. Okay. So do you see what's happening here? We've got a point, and every point now has a function on it called add, in addition to distance from origin. So every point we have, we can call distance from origin on it to tell us how far away from 0, 0 we are. We've also got the ability to add 2 points together, and we can do vector math on them, essentially, for physics. The third learning point for today is you can have a free function that does the same thing. So you can have a global function or a free function, however you want to call it. So I can make a function up here called add that takes 2 points, and they're going to be by const reference, point 1, const point reference p2, and we're going to return p1.x plus p2.x, p1.y plus p2.y. And so this function here is doing the same thing as this function here. I'm doing this version right here. So this line of code here and this line of code here are exactly the same. It's adding the x components together, it's adding the y components together, and then returning the result as a new point. So what this would look like down here, this is option 3. It's going to look very similar, but also different. So option 3, this is using a free function in global space to add 2 points together. Now, because it's not a member function on a class, we can't just say x, because we're not within the class anymore. So we're having to pass in 2 points, whereas this one you only have to pass in 1 point because the other point is me. Okay. Do I need a semicolon here? No. It's just a regular function. This is only used when declaring a class. So when you make a class, you need a semicolon at the end. This is just a regular function that takes 2 points and adds their x parts together, adds the y parts together, and returns a new point. Okay. And this one would look like this. Points 2 equals add points 0, points 1. Okay. So these 3 options are all doing the same thing. So this one is we don't have a function all. We're just going to manually add their x's together. We're going to add their y's together and make a new one and save it into the vector. This one is saying on points 0, call its member function called add and pass in points 1, and then save the result into points 2. And this one is calling a global function called add. Okay. And add takes in 2 points. Up here it's called p1 and p2. And we're passing in points 0 is p1 and points 1 is p2. Again, their x components are adding together, the y components are adding together, the return value is a new point, and that is going to go into the vector there. So you can see that these two things take like literally the same amount of typing, right? Like this line here, they take exactly the same amount of typing, right? And if you look at the function up here, you know, like basically between these guys and these guys, arguably this one's just a little bit more compact, maybe. You know, but some people like the symmetry of this better, right? You're calling add and passing 2 points to it. Some people don't like how this is a little bit asymmetrical, right? It's x plus px. It doesn't matter. It doesn't matter. It actually doesn't matter. Like literally all three of these options are doing exactly the same code. It'll probably compile down to pretty much exactly the same assembly if you have the optimizer turned on. Without the optimizer turned on, might be a little bit different, but these are basically three different ways that you can pass a point to a function and do stuff with it. Okay. So what I'd like for you to do now is write dot product. Okay. So the equation for dot product is x1, x2 plus y1, y2. So you're multiplying the x's together and you're adding that to the y's together. So you're going to make a function called double dot product, and you're going to put some stuff in the middle there. I'm not going to give it to you, and you're going to like write some stuff in here. And you can either do this as a member function or you can do it as a global function. It's up to you. Pick one. It's going to be very, very similar to this. Very, very similar to add. Except you're going to be returning a double instead of a point. So you're just returning a single number. Because you're multiplying the two x's together and you're adding that to the product of the two y's together. Okay? So start working on that for your lab time. Okay. And you're going to have to figure out what to put in here. You're going to have, I don't know, 10 minutes to do it. Dot product is very useful in a lot of circumstances. For example, if you want to know if two things are looking the same way, use dot product. And this can be very useful in video games and things like that. Let's see here, CSI40. Product. So if you have a normalized vector has a length 1. So this guy is 0.7, 0.7. So you have a person who's like looking in like this direction, right? And then you've got a thief, and the thief has like a knife, right? This is like a video game launch, right? And the thief is like stabs and like hits you. And the thief is looking like, I don't know, like this way. Not exactly the same way that you are. It's like a little bit off. The dot product is going to return 1 if you're both looking the same way. It's going to return 0 if you're looking perpendicular to each other, and it's going to return -1 if you're looking in opposite directions. Okay, and it ranges between these values. So if you're like looking like a little bit off, this is probably going to have a dot product of like 0.9. Okay, if the thief is here and like stabbing this way, this guy's looking that way, and this guy's looking this way, this will be a dot product value of 0.7. Okay. And then if the thief is here and stabbing like this way, it's going to have a dot product of 0. And if the thief's in front of the person stabbing this way, it's going to have a dot product of like -0.9 or something. And so what you can do is write code and say like if the dot product is like greater than 0.7, then like crit or something like that, right? So this is very common in video games where like you do a stab, and if you're stabbing somebody from behind, it does extra damage. So, or if you're programming like a vending machine and the vending machine's looking at you and you're looking at it, it's going to have a negative dot product. This is the kind of stuff that you learn in linear algebra. Linear algebra, which is super useful. Linear algebra is super useful stuff. So they didn't teach us this in linear algebra. I had to figure that out after I worked in the games industry. I was like, oh wow, this linear algebra stuff is everywhere. You know, these dot products and cross products and things like that are everywhere in video game development. That would have been really neat to know when I was learning it. So basically, yeah. So like if you're like here and you're like stabbing up and there's like a person here and they're looking to the right, then this is a dot product of 0. Okay, so this is not a backstab. But if you're like here, looking in like that direction, then that's a dot product of like, I don't know, 0.7 or so. And so that'd be Great. If you're standing in front of the person, they're looking at you, you're looking at them, you got your knife here, then that's a dot product of like negative 0.9 or something, not a backstab. Okay. So that's the use for this kind of stuff. So go ahead, and I'm going to give you guys 10 minutes now to code a dot product function that will take 2 points as parameters. If you're doing it in global space, if you're doing it in as a member function, it'll only take 1, and it'll return a double. Okay. So continue. I'm going to pause the recording now for 10 minutes. So yeah, there's a few problems with this. For example, here you're passing, this is missing point. So const point by reference P1 is correct. It needs point also const point by reference P2. And it's supposed to be returning a double, but you're trying to return a point. This probably won't work. These things need to be added together. So, and that should be an X instead of a Y as well. Yeah, so Hennard, this is wrong also. It just needs to be const point P1, const point P2. You can't do this. This is it's not allowed up there. Yeah, so Herbert, this looks good. This is correct. You're passing 2 points by const reference. P1 and P2, you're returning a double. You're multiplying the X components together, the Y components together, and adding the results. But here you've made a vector of size 2, and you're accessing the third element in it. There's only 2 elements, 0 and 1, both exist. Bruh.at2 does not exist. This is going to kill your program. Let's see, what else do we got here? This code is a member function version, which is fine, but the trouble is you're returning a point and not a double. You should be returning a double when doing a dot product. Dot products return a double, not a point. So this is close. This is correct, except this should be const reference. It's not going to affect the correctness of your code. This will return fine. It's just a little bit inefficient to pass a class by value when it should be passed by const reference, but it's not a big deal. It's a very small deal, honestly. It's a quibble. So you're multiplying the x's together, you're multiplying the y's together, you're adding them all up. Looks good, looks good. Okay, so let me show you my solution. So I'll do it both as a free function and as a global. So it's going to be const point by reference P1, const point by reference P2, and we're going to return P1.x times P2.x plus P1.y times P2.y. And so the dot product of these guys, the double dot product of 0 and points 1. So we've got 10, 0 and 0, 10. These two things are perpendicular to each other, right? We got 1 pointed east, 1 pointed north. These guys are completely perpendicular. So when we see out DP here, this is going to return 0. Okay. If we mess with this a little bit, like let's make this 0.7, 0.7, and make this one 0, 1. So we got one guy pointed northeast and one pointed north. Then we're going to get, they're mostly pointed the same way, right? So if you have one pointed like this, one pointed like this, they're mostly pointing in the same direction. So we get 0.7. What it's doing is it's actually returning the cosine of the angle between the two vectors. And these vectors have to be normalized vectors if you want to get a number from 1 to -1 on it. We can have like -1. So we got 1 pointed west, 1 pointed northeast. They're kind of pointed in opposite directions now. We'll get negative 0.7 out of that. So we can tell it's pointing in different directions now. So dot product, very useful stuff. If I wanted to do this as a member function, I could do so. Like this. And we are going to return my x times their x plus my y times their y. I don't need the braces. And there we go. So if I wanted to do it that way, you'd say points 0 dot product. And this line here and this line here do the exact same thing. Just one is calling a free function, a regular function, and one of them is calling, this one is now a member function. I'm calling dot product on it. So anytime you see a dot operator like this, that means it is a member function or a member variable of a class. So you can do it either way. You will get the exact same results. See, negative 0.7. Either way, you get the same results. It's just a matter of style. I've seen people argue very passionately for doing it this way or doing it this way. Either way works for me. I don't really have any strong opinions on the matter. Some people like the symmetry of this better because you got a P1 and a P2 and kind of like looks symmetrical. Some people like this because it's like it's part of the class. You know, it should be part of the class instead of like a global function. So just the style matter. It doesn't actually particularly matter very much to me. Because what I care about is correctness. I don't really care about philosophical things like that quite so much. Like if I'm making a software product, I'll probably hem and haw over it and be like, I don't know which one I like better, but that's it for today. So scale of 1 to 10, how complicated is this? The ability to put points into a vector. Like on a scale of 1 to 10. How complicated is it to like, do this, where you're just making 10 points all at once? 4s and 5s. So the tricky thing about this is that you're going to be doing like points dot at 1 dot x, right? So you're accessing the x of index 1, or points dot at 8, So there's like an extra level of indirection in there. But that's way easier actually than having a vector for x's and a vector of y's. Trust me, it's just like way easier to just have it as a vector of points, because each point has 2 variables in it. Each point is really just 2 variables living under the same roof as like roommates. Okay, so every time you make a point, it's really just 2 variables in one. It's 2 doubles, 1x, 1y. Okay, so every time you make a point, and we're making 10 of them, they will initialize themselves to 0, and you get an x and a y off each of them. Okay, how complicated would you say passing a class to a function is? Like this, where you're like passing a point to a function. So instead of passing an x and y separately, you're passing them in together under the guise, the alias, the name, P1. So when I could write a function that just takes x1, x2, y1, y2. It takes 4 parameters. Instead, I only have to pass in 2 parameters, one for the first point, one for the second point. Right? Like I could have made this add, I could have done it like this, right? Where I just have 4 variables. You're adding the x's together, you're adding the y's together. I could have made a add function that's just like add double x1, double x2, double y1, double y2, return x1 plus x2, y1 plus y2, like that. Like this would work too, but it's just more convenient usually to just pass it in as a point, right? So it's two variables coming together instead of having to like do each one of them separately like that. Just need to get used to it. Yeah, that's fine. Okay, and then the last thing we learned today is member functions. Does this make sense to you all? Like scale 1 to 10, how complicated are member functions? Where you can like have an operation you can do on a point. So you can say like, hey, point, how far away are you from the origin? And it will do like Pythagoras, right? Scale 1 to 10, how complicated are member functions for you? Those numbers are looking pretty good. So your next zyBooks is going to be due, I think, on Monday, and it's going to be on classes. So you've got a pretty good head start on that, I think. Your next homework assignment is going to be pretty fun. You're going to have to form a new group for this. On Friday, we're going to do lots of lab time on this topic. I'm just going to tell you now that you'll need to make a new group because they're maximum. It's really an assignment for 2 people. If you really want to, you can have 3 people in it. The homework assignment is called image processing. And you are going to be writing your own image filter, a Photoshop filter. So if you've ever used Instagram, you like applied a filter to an image, that's what you're going to be doing on this assignment. So it's a lot of fun. It's a 20-point assignment, and it's very easy to do. It's very hard to fail this assignment because if you try something hard and complicated, you can just scrap it and do something simpler. Now, you are graded on your technical difficulty, and you're graded on your artistic merit. I will grab my daughter and have her do guest judging of your Photoshop filters and things like that. Let me give you a short introduction to this. The full thing is going to be on Friday, like I said. But what your code is going to do, it's going to open up a picture, and it's going to run a filter on it, and then it's going to save the new picture, like an actual picture. Okay. So there is a file called filter1.cc. The first partner is going to be writing their code in that file. The second partner is going to be writing their code in that file called filter2.cc. You're going to have 2 separate blocks of code that you're going to work on. You don't need to touch main. Main is done. I wrote it. All the code to like open up an image and like save an image. I've done all that. You don't need to worry about it. This is using something called the CImage library that makes it very easy to open a file up and load a JPEG or whatever. Save a JPEG, save an animated GIF, that kind of stuff. So let's take a look at this real fast before we go. Filter1.cc. So you're going to write a function that takes a 3-dimensional vector. So you're going to take a 3-dimensional vector as input that is the image. You're like, wait, images are not supposed to be 3D. Images are 2D. Yes, they are. But at every row, at every column, there are 3 values there. There's the red, the green, and the blue. And they all range from 0 to 255. You know this from doing the Bridges Mountains assignment. So 255, 255, 255 is white. 000 is black, so on and so forth. So you can do something like this. This is a very simple image filter. You can say, so you can see the code here is running across every row, every column. So this is going to touch every pixel in the image. And we are saying, grab the red value at that row, at that column, grab the red value and double it. And grab the green value and double it. And grab the blue value and double it. So this is going to do what to the image? So if an input pixel is 100, 100, 100, which is like a medium gray, the output is 200, 200, 200. So what have we done with the image? If we double the value of every red, green, and blue at every pixel, what has happened to the image if we do this? It is not darkening. Remember, 000 is black, 255, 255, 255 is white. Yeah, you have made the image brighter. Quite a bit brighter, in fact. So, this here, I've got different examples. And like I said, we're going to do this for realsies on Monday or Friday. This code here is like doing like some sines and cosines and things like that. it creates like a vertical rainbow pattern across the image. You can see that when you run it. You build the code by hitting make, and then you're going to run the program. And if you run it with no command line parameters, it's going to tell you, pass in a JPEG file. So you can run, for example, a.out public Kyoto.jpg. And if you do that, it'll load this 4K image. Maybe it's a 1080p image, I don't know. And then it runs filter 1 on it. Then the output of filter 1 goes into filter 2, and it runs filter 2 on it, and then it saves the results. So filter1.jpg is the result after filter 1 runs, and then the output of filter 1 goes into filter 2, and then after filter 2 runs, it saves that. So what you're going to upload next week is you're going to upload your original image. You're going to find an original image. You're going to upload the original image with filter 1 applied, and you're going to upload the original image with filter 1 applied, and then filter 2 applied after that. So boom, boom, boom. So you're stacking 2 filters on top of each other. And if you have 3 people in your group, you're going to upload the original with filter 1, the original with filter 1 and filter 2, the original one with filter 1, filter 2, and filter 3. So you're going to upload 4 files in that case. And it can get pretty chaotic. And so that's why I said this is really better with 2 people. You can self-sign up on Canvas for the groups. It's really like you are judged on the artistic merits of the thing. So having 3 Photoshop filters applied at the same time oftentimes creates a lot of chaos. If you want to view an image inside of PuTTY, you can use WinSCP. If you remember WinSCP, you can copy JPEG files to and from the server. You can do that. There's also a built-in text image viewer that I wrote, so you can like look at the look at an image low res style, but you can like at least see it. So if we got that guy there, we could run a.out on Dewey, and then we can like view it, filter 1. So you can see it's been brightened. It's a lot brighter than before, and you can see it's got these rainbow patterns going across it now. And then if you want to look at the output after filter 2, you can see it's been vignetted. So filter 2 is a vignette, okay, so which darkens the edges. So that's maybe easier than copying it to and from or whatever. So that little preview, we're going to be working on that on Friday at lab time. You're going to have lots of lab time on Friday. You can request me to write a image filter, and I'll just do it live for you. I've got tons and tons of image filters that I've written over the years. And this is a fun assignment. It's really neat. It's 20 points. Have fun with it. Talk amongst yourselves now to find a partner, and then go on to the groups section of people on Canvas and sign yourself up for a group. I'm not going to group you guys up. You guys group yourselves up. Okay? Spooky filter. That could be fun. So that's it for today. Thanks for coming out, and I will see you guys on Friday. Peace.